either heat it, or you can hammer it, or you can drop from a height multiple times. Earth itself is a giant magnet, correct? So if you consider Earth as a giant magnet, then this magnet also has two poles. Do you agree with it? Hey budding charms, I hope everyone is doing well today, and we are back with an amazing rapid recap session on the topic called Fun with Magnets. My name is Aishwarya Sindhu Ramachandran and I will be a science educator today, and let's get started. So before that, please have a notebook and a pen along with you so they can note down the important points, as we are going to discuss multiple concepts today. Not only that, if you find any kind of doubts in between, please don't hesitate to ask your doubts in the comment box. So let's dive into the session. So before that, I would like to tell you the basic contents that we will be learning today, starting from material types, magnet types, properties of magnet, magnetization, and finally demagnetization. So these are the basic concepts that we will be learning today, and let's get started. And here you can see that materials are being basically classified into two, as magnetic materials and non-magnetic materials. What is meant by a magnetic material? A material that gets attracted by a magnet can be called it as magnetic material. So let's have some examples here. So please write it down. Iron and cobalt. So iron and cobalt are considered as magnetic materials. And what about non-magnetic materials? Very simple, that these materials cannot be attracted by a magnet. So it's a very simple one. So let me give you some examples on this. Wood, plastic, glass, all of these come under the category of non-magnetic materials. Please write it down. Wood, plastic, glass, etc. And I hope you're clear. Take down the notes, very important. And now we are moving towards the next concept. And you can see that Arun's magnet is being attracted by this huge magnet here. How is that possible? Don't worry, let me break it down for you. And here you can see that what is meant by a magnet. So what is meant by a magnet? Can anybody tell me? Very simple. It's nothing but it can attract other magnetic materials. Very simple, right? So let me write it for you. Magnets attracts magnetic materials. It's a very simple concept. Magnetic materials. So a magnet can definitely get attracted to iron, nickel, cobalt, etc. But why is it able to attract the other materials like this? Just because it has something called magnetic field around it. Magnets are able to produce magnetic field around it, and that is what the reason these materials are getting attracted by a magnet. So it's very simple, right? So you have to write the second point. It produces magnetic field. Please write it down. Very important. Magnetic field. And I hope you're clear with the point here. And now we are moving towards the next one. It's all about types of magnets. So magnets are basically classified into two, as natural magnets and artificial magnets. Very simple. You can see that natural ones are found naturally on Earth. So lodestone is a great example for it. You can write it down. Lodestone. So lodestone is an example for a naturally found magnet on Earth. And what about artificial ones? Artificial ones are nothing but the man-made ones. So very simple, it can be found in different shapes. So let's start off giving the names. This is a Mar magnet. This is a horseshoe magnet. Please write it down. Horseshoe magnet. And this is nothing but, what it is? Disc magnet. This is cylindrical magnet. Cylindrical magnet. This one is going to be ring magnet. And finally, this is the spherical magnet. So these are the man-made magnets or artificial magnets. And now what we are going to learn is all about the magnetic compass. So you might have seen at least in films, right? Yes. So magnetic compass is nothing but a device that has been used by ancient people to navigate from one place to another. You might have seen in Titanic film too, right? Yes. So now we are going to learn the different parts associated with it. And here you can see that this is nothing but a magnetic needle. Okay. So this has a magnetic needle. Very, very simple. And it has a glass top. Okay. And it has a container too. So it has a container, on the top there is a glass one, and inside that the needle has been placed. So that's all about the parts of a magnetic compass. Next one, it's all about magnetic poles. So what are magnetic poles? If you consider any kind of magnet, it has two poles. And what are these poles? A north pole and a south pole. If you take any kind of magnet, whether it is a horseshoe magnet or a cylindrical magnet or a ring magnet, it has two poles, north pole and south pole. And why these poles are so special? So these are the places of a magnet where the magnetic strength is maximum. So you can find magnetic strength maximum at these points. So magnetic strength, write it down, is maximum at these poles. Okay. So now we are going to learn something very special. It's all about the properties of a magnet. So for that, we need to consider two magnets. So in the first case, I'm taking two magnets and trying to keep them together with different poles. Look at it. In this one, north pole, and in this one, it's south pole, right? So I'm trying to make them placed together. So what will happen? We have different poles together, so they will attract each other. So this is a very important property of a magnet. That's nothing but when two opposite poles come together, they attract each other. And what about the second case? This is a second case. You can see that here it is north pole and here it is also north pole. So what happens? We have similar poles. So when I try to make them closer, I will not be able to, right? We have same poles here. So they will repel each other. They will not attract. They will repel each other. So as you keep two same type of poles together, they cannot attract. Instead, they will repel each other. What about this one? Again, south and south close. So what happens? Again, similar type of poles. So they repel each other. So from this, we can understand that if two similar poles come together, they repel each other. And if two dissimilar poles come together, it will attract. So that's all about it. And now we are going to learn about magnetic field. And a magnetic field is nothing but a region around a magnet where magnetic effect can be seen. And you can see that this is represented by magnetic field lines. And these field lines always start from north pole and ncert south pole. So please understand the point. Magnetic field is nothing but the region around a magnet where the magnetic effect can be seen. And this is represented by magnetic field lines. And these field lines always start from north pole and ends at south pole. Got it? And now it's all about freely suspended magnet. So if I try to suspend a magnet freely like this, the magnet automatically gets aligned to a north-south direction. How is it possible? That's what we are going to learn next. And for that, you need to understand the magnetic poles of Earth. So before getting into the magnetic poles of Earth, let me tell you the geographical poles of Earth. So if you take Earth, it has geographical north and geographical south. Correct? So this is all about geographical north and south. Okay, and what about this one? I told you Earth itself is a giant magnet, correct? So if you consider Earth as a giant magnet, then this magnet also has two poles. Do you agree with it? Yes. And now you can see that this is the south and this is the north. I am representing here as well. So this is nothing but the magnetic south and north pole of Earth. So this is all about Earth's magnetic south and north. But how a suspended magnet gets aligned to north-south direction? That's what we are going to learn next. Look at it. In this particular one, we can see that we have a north pole and we have a south pole. So this bar magnet's north pole get attracted by the magnetic south of Earth. Please understand, magnetic south gets attracted to north pole of the bar magnet. Similarly, the bar magnet's south pole gets attracted to magnetic north of Earth. So this gets attracted to magnetic north of Earth. Got it? And that is what the reason the freely suspended magnet gets aligned to north-south direction. How to make a magnet, and here you can see that this method has a very specific name. This is called magnetization. Please write it down. Magnetization. So for that, you need to take a magnetic material. Then you need a perfect magnet. I'm taking a bar magnet here. Now what I'm going to do is going to rub in the same direction for 30 to 40 times. So I'm going to rub it for 30 to 40 times so that this magnetic material becomes a magnet in some time. Got it? And please make sure that you have to do the process in the same direction always. And you should not make the bar magnet away from the material. You have to make it very close and rub it along the same direction continuously. And I hope you're clear. And now we are going to learn laws of magnetic property. So laws of magnetic property is nothing but the method of demagnetization. Write it down, very important. So this is nothing but demagnetization method. So demagnetization, and for that there are mainly three methods. You can either heat it, or you can hammer it, or you can drop from a height multiple times. So these are the ways in which you can make laws of magnetic property from a magnet. And now it's all about breaking a magnet. So here I'm going to break the magnet into three pieces. So that's what. So these are the two positions where I'm going to make the break. Okay. So I got three pieces in total. So if I try to break a magnet, each piece becomes an individual magnet. Please understand, if I take a huge magnet and try to break it into three pieces, each piece becomes an individual magnet. Got it? So each magnet gets two poles. Do you agree with it? This has two poles, this has two poles, and this one also has two poles. So total of 6 poles are produced when I broke this particular magnet into three pieces. And now it's a summary time. We started with material types, magnetic and non-magnetic. Then we discussed about the definition of a magnet. A magnet can attract other magnetic materials. Then magnet types, natural magnets and artificial magnets. And now properties of a magnet. We discussed that magnetic field lines can be produced, and we discussed how a magnet can be broken into different pieces and how the poles are existing there. Then we discussed magnetization, the way in which you can make a magnetic material into a magnet. Then demagnetization is a method of removal of magnetic effect from a magnet. So that's all we learned today. And thank you so much, and I hope everyone really liked the session. And that's the end of the class. We'll meet next day with an amazing session similar to this. Till that, have a nice day and goodbye, students. And